In a study of the speed of muscle contraction in frogs under various loads, British biophysicist A.W. Hill determined that the weight, which is represented here by W in grams, placed on the muscle, and the speed of contraction, which is represented here by V, which in centimeter per second, are approximately related by the equation of the form given over here, which is W plus A times V plus B equal to C. So here we have a relationship between W and V given by this equation, and we also have those A, B, C which are given as constant. So far we have just given a relationship between W and V, or the relationship between weights and speed of contraction. So what is the question here? We also have given, it looks like, suppose that those constant are actually for certain muscle is given as A equal to 15, B equal to 1, and C equal to 90. So if that is the case, let's try to write down with those particulars constant our relationship between W and V. So we have W plus A, which is 15 on this case, right? And then V plus, and then B is 1, so that's also given. Let me replace that, and is equal to 90. So this is a relationship between W and V based on those given constant. The question here is we need to express V as a function of W. So that's what we need to do. So let's try to do that. So but how can we do that? You can see here there is a relationship between W plus 15 times W and V, which is given as W plus 15 times V plus 1 is equal to 90. And if that is the case, you can clearly see here, because there are two factors over here, one completely look like kind of W plus 15 and another is V plus 1. So if that is the case, if we need to solve for V in terms of W, then the easiest idea could be just divide both side by this factor that is given over here as W plus 15. So when we do that, we'll get this. And when we subtract 1 on the both side, we get 90 over W plus 15 minus 1. And this is already a function of W. So we already express V as a function of W. But if you want to rewrite this, we can also like find the lowest common denominator between these expression over here, which is W plus 15, right? And then we get 90 minus, so there is only 1 divided by 1, something like that. So to make the denominator perfectly equal to the lowest common denominator, we need to multiply by W plus 15 to the top and bottom, and then we will have this term over here. So now let's distribute by the negative sign. Then we get 90 minus W minus 15 divided by W plus 15. So we get 90 minus 15 is 75 minus W divided by W plus 15. So this could be another alternative where we have also expressed V in terms of W. So we are done with this first problem where we needed to express V as a function of W. The another question we have here is find the concentration if a weight of 16 gram is placed on the W on the muscle. So if that is the case, we have given W equal to 16 on this case. And then we need to figure out if W equal to 16, what would be V. So we have given W is equal to 16. So we need to figure out then what would be V when W equal to 16. But that can be just evaluation of this function V when W equal to 15. Either you can use this expression or that, whichever you want to use. We can just use that and then figure it out. So V is equal to, if you use 75 minus W over W plus 15 type of expression that we have figured out over here, then actually now we to figure out the speed of contraction when W is 16, that means evaluate the function V at 16. That can be done by 75 minus 16 divided by 16 plus, by the way, it looks like I have not correctly written the function, which is W plus 15. So we can just write that down And now you can just use your calculator and then see if you get approximately equal to 1.9032. If you like to write down the units, we have given that the speed of contraction is in centimeter per second, so we can just write that down. Okay, we are done.